Hey everybody, this is Larry. This is day 26 of the January Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's forum. Today is a Saturday here in New York City, though I guess 26 is a Sunday. But yeah, how do I feel? My leg still, my foot still hurts a bit. I have it elevated, so I'm like in a weird, like my foot is up in the air kind of situation. I woke up and it was way worse, but then I took another nap and then now it's manageable. But I thought about going for a run. I couldn't. I was trying to go for a run in the morning, but I was just like, yeah, could not wake. Or I woke up and then I just my foot would not wake up. Everything hurt so much. But I took a nap. It was okay. And then I was tempted to go, but I think I've been pushing myself a bit hard. So I'm just gonna. Took the day resting is my point. Anyway, I don't know if anyone cared about that one, but just want to give you an update because I've been talking about it the last couple of days. I am running a 10K next Saturday. I was kind of hoping low-key going for a PR, which is not, because my PB, I haven't ran that many 10K, so my PB wouldn't be that high anyway, or that, difficult. But now it's probably, I don't know, not happening, so we'll see how it goes. I mean, it's not a big deal anyway. It's just a 10K, right? But that's the thing, right? Is that is the same with Leetcode contests, right? Like, if we do well in one contest or whatever, like it's great and it's fine, but it's like, well, if I did well in this contest, would I accept that being the best contest of my life, right? And the answer is probably no, right? And what I mean by that is that, like, okay, if I get a PB. Personal best. Sorry, if I get a PB in the weekend or next week on a 10K, like, would I feel great? Yes. But if I don't, would I feel not great? I'll be okay. I mean, especially now that I'm injured, because look, I'm trying to be fast, not just for this race. I'm trying to be fast, in the long run, right? And in the long run, as long as you keep going. In my case, if I keep running. I'll get better. I have no doubt about it. I don't worry about it, right? The only question is whether I will put in the work. And, well, maybe the other question is whether I'll get injured, but that's, but yeah, so that's kind of, hopefully you can draw your own parallels there with, it's okay to just, like 1 day, 2 days, whatever. But as long as you kind of come back to it, remain consistent and make gains, if you will, everything will be fine. All right, let's take a look at today's problem. Today we have 2127, maximum employees to be invited to a meeting. It's a hard problem, so hopefully, not too hard because the contest, I think it's in an hour. I never know because I don't know, daylight savings, I get confused a lot. So it's in 55 minutes. Hopefully we finish this before then and I could get a snack or a rest anyway. All right, let's take a look. We have 2127 maximum employees to be invited to a meeting. A company is organizing a meeting and has a list of N employees waiting to be invited. They're arranged in a large circular table capable of seating any number of employees. The employees are numbered from 0 to N-1. Each employee has a favorite person and they will attend the meeting if and only if. No, it's not an and only if. They will attend the meeting only if they can sit next to their favorite person at the table. The favorite person of an employee is not themselves. I don't know. I feel like I'm usually my favorite person. But okay, fine. Weird problem aside. Given a zero index of integer where favorite, where favorites of I is the favorite person of the I employee, return the maximum number of employees that can be invited to a meeting. Okay, I mean, I think there are a number of ways that we can think about it. The fact that it's circular is a little bit, I don't know. But you can again think about it as a graph problem, right? Maybe. I don't know. I mean, this is definitely a tricky one. I think the hard part isn't like having an idea. I think we can come up with ideas and there'll be heuristics, right? But the hard part is just trying to prove your ideas or your heuristics are actually correct, right? And I think that part is maybe a little bit tricky because you have this. What is that? Oh, 0, 1, 2, there's 3. Oh, because you can only sit next to 2 people. Actually, I did miss that. I'm not gonna lie. I did actually. But I mean, I had a brief moment of like, oh yeah, you can only sit next to two people. And then I was like, oh, but that's just like a graph. And then when I had the graph in my head, I was like, oh, I forgot about the two people part until I read this. So sometimes it's useful to have abstractions, but don't forget your restrictions, which happens to me a lot. Okay, well, and now that makes it a little bit even trickier, right? Because then now you can just do greedy in a way of like, okay, well, because you're only limited by two people, or at least two people. I want to say that there has to be a cycle, right? But there's only one cycle, unless I don't know if this is like a case enumeration thing, right? So okay, so we can so there I don't know. I don't know if this is the way to solve it, by the way. This is a hard problem. I don't memorize problems or solutions. So I don't know this one. I probably solved this one. You might even watch a video on it that from me in the past, but I just don't remember it. Okay, so there are a couple of scenarios. One is that there is a cycle of more than two people. Well, if there's a cycle of more than two people, then they have to take the entire table, right? Because you can just think about it. If like, if you just draw it out like in actually, I guess I could draw it out. Maybe today I'll be a little bit less lazy. Well, not even lazy, just that I think maybe this is a little bit more clearer. Hang on. Though it is a very awkward because of my foot situation. What an idiot. Talking about myself, of course. But yeah, but for example, if you have like this person wants to sit next to this person, wants to sit next to this person, wants to sit next to this person. Well, and you could kind of, by almost induction, you could inject more people, but and of course, just to also be clear, this is a functional graph, which is a fancy term. I don't know if you need to know it, but it just means that each node has one outgoing edge, right? But you can do induction, and if you look at this, right, you can draw it like a circular table, and that means that if there's a cycle of length more than 2, then that has to be in the table, or they're not on the table at all, right? Okay. Then the other one is that maybe it's just yeah, no, that's right. Right? Yeah. The only other case is that if you have groups of 2s, right? Because groups of 2s, you have this, but then on a grand table, you think of it as a table. They could sit next to each other, and even in fact, a couple of people can add on to it, and then maybe you have another, love fest over here. So in that way, you could chain together all the 2 cycles, right, into the same table. So I think those are the only 2 cases, because you can't really fit another person in here and up there. Here is just, well, that is all you get, and you cannot fit another thing with more than 2 people. And of course, every node has to love someone, and so this person has to either, like, if you think of it, adding a new person to this table, right, it has to basically, okay, well, this person wants to be with this person, right, and this person either has to see a new person or go back, right? But in this case, if you already add to 3, then you cannot go back, as we said, because the table just, that's not how the physics of the table work. And so this person has to only really go back to one person, and so forth. But in that way, it's just what we said, right? And of course, actually, there's actually, you can have actually 2 tails if you like. But okay, so I think those are the 2 ways. I don't really have a great proof on this, honestly, other than kind of what I showed you with, like, by visualization. But that's not a proof per se. Or in a sense, it's not complete proof anyway. It's a proof that you can say that this part is good, and maybe this part, maybe you could say induction or whatever. But is it like, like, I proved that for these cases it is correct, maybe, right? But it doesn't mean that there are no other cases, right? Like, can you prove that you're exhaustive with respect to the number of things? I don't know. But anyway, each person, and no one can like themselves. So, okay. So I think with that idea, I can at least YOLO try a little bit. I don't know that. Honestly, am I 100% confident? Not really, but I am also like moderately confident just because I think those are all the cases really. But that's not a proof. That's just my feels, you know, my vibes. But yeah. Okay, so then now here we just have to figure out cycles, right? How do we want to write this? This is actually annoying to think about writing it, but yeah, but we can write it. 2 cycles, right? So find all 2 cycle things, people, right? So and that's a little bit easier, right? Because then now you can say favorite of I. So that person, right? So that person is equal to I. So if this is the case, then pairs, let's say, right? You can say we don't even need to kind of group them because we don't need to define it. But yeah, maybe it would just be like you could say safe maybe, because I was thinking about a safe node, but like I don't know. Let's just say good for people. I don't know. We could append I and also append favorite I, though I think if you go to favorite I, it'll go back, so I don't know. So it's probably the same. It's probably fine. You can also put it in a set if you like. But yeah, I think if you just do it this way, then it'll get rid of the symmetry. Or there will be a symmetry, so you get rid of the duplicates, is what I mean, right? So then now you find all 2 cycle people, and then now, right? Actually, I do want it as a set. You know what? No, it's fine. Okay. I'm just trying to think, right? Okay, maybe good is a terrible thing, but 2 table maybe? I don't know. Naming stuff is hard, as you can see. But yeah, but then now you can do either breadth first search or depth first search. It doesn't really matter, right? So then now we go. Actually, I do want this as a set, because then now you could say if and here we can say maybe done is equal to force times n, and then if not done sub I, then we go yeah, just naming stuff is hard. That's the part I'm struggling with. Is on table maybe? Is table? Whatever. Is table. If it's table, then yeah, table. Actually, I think we could just write something like calc table or something. Not even that. And what I mean by that is that you can just do calc table. We have the current person, right? Let's just mark x is equal to true, and then oh, there's no for loop because you only have one person, right? So calc table, you want something like calc table favorite sub x, right? And then you go there. But then the question is, okay, well, if not done favorite sub x, then we do this, right? But this one we want to return a value, which is that yeah, if x is in table, return true, right? So I kind of want a memorization actually, so I think this is kind of terrible the way that I'm writing it. But yeah, but maybe actually I can just write maybe that is the way to think about it. It's just memorization, because I am writing this in a funky way, honestly. Okay, right. So if not done sub x, then if done sub x, then we can return whether x is in table, right? Otherwise, done of x is equal to true, and then we calc table for the thing, right? So if this is that means that if there's a way to a table, then now we want table at x, and then we return, well, in this case, we return true, right? Yeah. And then now we can just return length of table. This is not the answer, by the way. I just want to test it real quick. Make sure that I don't do anything funky. Okay, that is true. I think I forgot about this case, so that is a little bit wrong. And this is the case where we were talking about. So we have to find, that is actually tricky. So I have to rewrite this. I'm wrong. I think what I said was mostly right, but like I said, sometimes it's hard to remember all the cases, and I forgot one. And the case that I forgot is just that if, which is example 1, right? If you have something like this, actually in this case you have this, but then now you have, oh, because basically you have this node and this node, so this cannot happen, right? Or like you have to pick one of the branches. Let me choose the color real quick. So something like this, you have to choose one of the branches, and you can choose both, which I did by I don't know, just by sloppiness, I think. Okay, this is a very annoying problem. So let me think about it. Even if we have the idea, we have to think about how to write it, and I have to think about it a little bit. Okay, I mean, I guess we can go the other way, right? So okay, fine. Yeah, okay, fine. Let's rewrite this. So then pair is equal to right? So here, that's just wrong anyway. So then now we want to process I and favorites of I, and maybe we do have a table thing here, right? This is so annoying. But let's get the reverse graph, right? So for index x in enumerate favorite, we have, so it means that index favorite is x. So then now we want to say reverse graph of x is append index, right? Something like that, right? And then now we just go in reverse of I and favorites of I. We know that they like each other, but then now we have to go through all the other nodes, right? Yeah. Maybe we can even convert this to a set. So then, for the reason that I can just remove the reverse graph from each other, right? So right, now that we remove them from each other, then we can now just go find the longest branch of either one of them, right? Yeah, might have to clean something up. This is such a mess. Okay, fine. Right, so then now just get max, right? Max left is equal, I just call it left, whatever, go, whatever. Naming things is hard, so. Oh, what am I doing? This is I and favorites of I, right? Anyway, and maybe if you want to not do duplicate, you can just make sure that I is less than favorites of I or something, right? And the reason is because then now it breaks the symmetry, if I could type it correctly. Yeah, and then now it should be 2 plus max left plus max right, and that is the end. That is the result we added to this, right? Yeah, and maybe, yeah, okay, let's just do it that way for now, right? And here we have go, which is a terrible name, but I don't know. So we start from x, we go up the reverse graph, right? So for v and r sub x, yeah, I mean, there shouldn't be. I'm trying to think whether there can be other cycles, but that's not, I don't think that's possible, right? I mean, because of just the way the graph, because it is a functional graph. That's why it's not possible. So, plus 1 or something like that, right? Yeah, okay. Right, so max is equal to 0, right? And then max is equal to max of the max value this, and then we turn max. Very simple. Let's see if that at least gets some of it right. No removal. Ooh. I don't know how that happened, but okay. Max with a value. Oh. Huh. Okay, so it works for this one because it is the graph that we were saying. This one it doesn't because you want all 4, right? This is not a 2 cycle, is what I mean, because they have a this is a 4 cycle, right? I think, yeah. Oh, and those are the only that's case 3. Okay, so case 3 is a 4 cycle, so that's why it's returning 0, which is expected because we didn't handle that case. This one is a 3 cycle, so yeah, this one is a 3 cycle, so also it's not handled by our case. I think I mean, I think what I would like to do, but maybe I'm not going to do because I do want to. I want to make sure I have enough time for the contest. My apologies. But what I would do if I had more time is just write more tests for this case and make sure that it fits for the two cycle case and then branch out, right? Okay, now, okay, so that's a possible answer, right? Wes has the result for the combination of all the 2 cycles, right? So then now we go. Yeah, now we try to find all the other ones. And actually, I mean, I think, yeah, these should be linear, but I think I want to just be lazy and write a loop so that we don't calculate it in this step, right? Because this is very funky to look at, but you could think about it as max left is the root of a tree, or linked list in this case. So in that case, even though this looks like it may do something n squared if you're not careful, because you only run this at the roots, it's linear amortized or summation, if you want to call it that. So that's why it's fast enough. But here we don't want to do things we've already seen, so maybe we just add like a done thing, right? Yeah, and then now we can just do again. Okay, so now we have nodes that are not part of the 2 cycle. So yeah. Then now we maybe calculate again. So we have to find the cycle, right? So yeah. And here maybe I don't want to do it recursively. I want to do it with inputs. It's not even a stack, because the one thing about functional graph is that it allows you to do these kind of shortcuts, right? Because it only has one out and one in. So then if there's a cycle, well, there's no other way to go get in and out. They all have to be cycles, right? No, that's not true, is it? Huh? I think I missed the case. I missed the case where you can. I'm going a little bit fast, maybe, but basically you have something like this, and I'm missing the case where. Okay, so you have a cycle of 3 items. Oops, that's not. Oops. But then you start at this node, then that's no bueno, right? How do I handle that in code? I mean, it's not that hard. I guess it's just the usual. I mean, you even use, if you really like, you could even use what's that called? Freud's tortoise and what's it called? Hair algorithm. Sorry, I had ice on my foot. I had to remove it. So yeah, we can definitely do that, right? So yeah, so maybe we can write something like scene is equal to right? And then current is equal to I. While current is not in scene. Or not, yeah, actually. But what I actually want is an additional thing, like step is equal to 0, while current is not in scene. Scene dot add current, right? Oh no, that's not right. That's a set notation. So current is equal to step increment by 1, right? And then now scene is in current, so then scene of current minus step is the length of the cycle, and then we just care about the cycle. So we just want the max of the thing and the cycle, and that should be good. Okay, maybe not. Though this is, I messed up here as well because we have to actually mark all these as done. Otherwise you do get into n square thing. But why is that not working? But yeah, okay, let's just mark. I mean, this should not fix things because this does less work if anything. But okay, still wrong for 0. Do I accidentally do anything funky? 0, 1, 2 is 4. So okay, so it does stuff. So it goes from 0. I'm dumb. Of course. I forgot a critical step, which is moving up current, right? Current is equal to favorite of current. Whoops. Okay, still no bueno, but Scene of current. Oh no, it's the other way around actually. That's why. Well, I don't know if that's why, but my math is just bad. I mean, that's definitely not helping, right? So okay, there you go. Is it good enough? Honestly, not 100%. Especially now that I keep on running into silly mistakes. Not 100%, but enough to YOLO. All right. Very slow actually. But that's it. Oh, did I do something wrong? No, it seems okay. In terms of complexity, I mean. I think this is still linear, though. Is it linear? Did I do something dumb? It feels slower than I would like. For 2 seconds for 10 to the 5th for linear is a little bit slow, honestly. I'm definitely slower than I've done before. But maybe there's just a faster way of thinking about it. But in any case, this is linear time. It should be, unless I made some silly mistake, of course. I don't know. Why is this so slow? What am I missing? It feels a little slower than I would have expected, honestly. I mean, it's still linear time, but or it should be. Like I said, maybe I made a mistake somewhere. I don't know. I mean, this is linear. This should be linear. But like I said, you only remove the node, right? So maybe I can do a assert done of x is equal to false. So that's technically not Pythonic. Right. Yeah, so we only do that each node. So this part is linear because we only do each node once, right? And then this thing should also be linear, right? I know that's not Pythonic, or that's not even me. Okay, so maybe we do some dupes here. Because here, that is very odd. What? Wait. Oh, whoops. I thought this was a print statement. That is obviously not a print statement. Kern, tons of kern. Right. So this is what on. What is this on? Hate this UI. This is on case 2. Let's see. Is this case 2? 2, 1. This is case, no, this is case 1. So you have 0, 3, 4 as the cycle. Then you have stuff hooking into the cycle. But then current would be, oh, it's not seen in the current one. So this is maybe n square actually. Maybe I messed up somewhere. I guess, okay, so I think I missed it, because basically everything into the tail, yeah, this is wrong, complexity wise. I mean, obviously it works, but, well, I don't know. I mean, it just works by luck, honestly. Okay, so we have to clean this up a little bit. Because we only check on the entry point, right? So then now, if we go into a cycle where it is done, if this is done, that means that we've already done this the thing, so we can break. I don't know if that affects. No, that means that the cycle. Oh, we already kind of calculated the cycle in the past, so I think this is okay. Maybe. Okay, well, but except for that, now we don't update this. So okay, well, this is very awkward. So if the new node is already done, then yeah, okay, fine. Even though we didn't see it in this iteration, I mean, I think this is yucky, but just do something like this. So you want the only two exit points, either this or this, right? So then now, if good. That's a very sloppy mistake by my part, though. I can imagine that I can imagine that it times out and I'm silly, but now it's wrong. Good. Done subcurrent. Current would remove current. So current, it's in scene. Oh, I see. I think it has to be here actually, because if current is in scene, then done is always going to be good. So okay. Yeah. All right. Let's give it a quick submit. Give it a try. Without the print statements, probably would be pretty nice. Give it a spin. Okay, I mean, there you go. I mean, is it fast? No, but it definitely is at least much faster, right? Like a 2-second difference. So definitely I made a mistake in, because basically what happened is, and this is actually reminds me of the star graph thing with tree problems sometimes, is that you have something like this, right? And then you, you have, more nodes, right? And then here, let's just say your first, or it doesn't even matter your whatever, but let's say you calculate, you have this node, you calculate for this one, you go, okay, this is not done. So then now we calculate this, we calculate these things as done, right? However, when you're now looking at this node, you go, okay, well, we have to go enter it, right? And then now, but you have to do all these things again, even though you've already done it. So, and this one again. So in that way, it can be n square, really. If you really, you can construct an n square case and time it out. It's just that I was very lucky to not run into it. But the way that this fixes it is because, well, if we already seen this cycle before the current iteration, that means that we've already previously calculated this, so we don't have to do any more, and also just to terminate so that we don't do the cycle again. Now making it actually finally linear again. Very easy mistake to make, as you can see, because I feel like I'm very experienced, right, and practice, and I made that mistake. It's just so easy to make. I think what happens is that generally I write this top down, but I don't know that that's a good excuse, honestly. But anyway, yeah. So this is gonna be linear time. This is linear time, as I said, because you only go from each root. Here you only go from basically any branch. But yeah, but now you only look at each node once. Alternatively, you could have also cached the answer at each node, and then if that node has an answer, then then you don't do it. But I think that's roughly the same idea. I'm curious what I did last time. I guess I did the same thing-ish. Go and go to this one for the cycle. But it was slow, so was that why I kind of wrote an optimization? Past Larry. Yeah, it seems like I did the same thing with the early thing. So I don't know. I guess we're consistent, and I would have timed out twice. But yeah, that is all I have for today. Let me know what you think. Thanks for watching. And yeah, if you're doing a contest, stay good. Or good luck. I don't know. But also, if not, or even if you are, stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.